We now want to determine whether the series is convergent or divergent, looking at the series k equals 1 to infinity of k factorial divided by k to the k power. When I have factorials, it's sometimes helpful to make life a little bit easier by comparing to something else. So I'm going to look at my term, k factorial divided by k to the k power. Remember, k factorial is 1 times 2 times 3 times 4, so on and so forth, up to k minus 1 times k. There are k factors on the top of this fraction, so I can write out k to the k power as k times k times k times k, so on and so on, k times k. And I've made the k's on the bottom visually line up with the factors on the top because there are the same number of factors on the top and on the bottom. I know that k over k, of course, is 1. Moving to the left, k minus 1 over k is less than or equal to 1 because the top of that fraction, k minus 1, is smaller than the bottom of the fraction k. We can continue this argument all the way down. We know that 4 over k is less than or equal to 1. We know that 3 over k is less than or equal to 1. And that is as much as I want to eliminate. Overall, I've decided that this large fraction is less than or equal to 1 times 2 divided by k times k, or in other words, 2 divided by k squared. The reason I've decided to keep the first two factors is so that I have a k squared on the bottom. We know that the series 2 divided by k squared is a constant multiple of the series 1 divided by k squared, and we recognize this as a p-series. This p-series has p equal to 2, and so it converges. Since we've shown that k factorial divided by k to the k is less than or equal to 2 divided by k squared, by the comparison test, the series of k factorial divided by k to the k also converges. Now, let me point something out. Suppose at the beginning I also said, oh, well, 2 divided by k is less than or equal to 1, and therefore my term is less than 1 over k. Well, if we look at the series 1 over k, we know this is a p-series with p equal to 1, so it diverges. Okay, now our inequality is still true, that k factorial divided by k to the k is less than or equal to 1 over k, but because the series 1 over k diverges, the comparison test tells us nothing. Okay, so my point is that if you are using the comparison test, you need to make sure that your term is less than or equal to a term that you know the series will converge, or you need to make sure your term is greater than or equal to a series that you know will diverge.